All right, graphing functions in standard form. So standard form is ax plus by equals c, where a, b, and c are constants, which means they're numbers. So we're just going to start off with examples. The first one is 3x plus 4y equals 12, so that's in standard form. And so let's write out the steps that we do this. The first one is that we plug in 0 for x to find the y-intercept. Then we plot the y-intercept. Step 2, you plot it. Step 3, you plug in 0 for y to find the x-intercept. And then step 4, you plot the x-intercept. And then 5, you draw a line through it. So let's see it in action. We're going to plug in 0 for x. So 3 times 0 plus 4y equals 12. So that 3 times 0 can go away. And we get y equals 3, which is the coordinate 0, 3. So if we draw that on a graph, we need to draw it on the y-axis, 0, 3. So I need to make the top a little bit bigger. So that was step 2, was plotting that. Step 3, we plug in 0 for y, and we get 3x equals 12. So x equals 4, and that's the coordinate 4, 0. And then we can draw a line through our 2 points, and we're done. Let's look at the next example. So we've got 2x minus y equals 4. Let's draw our graph. Straight lines are really not my strength. So step 1, we plug in 0 for x. We get negative y equals 4. So y equals negative 4. So the y-intercept is 0, negative 4. Then we plug in 0 for y. We get 2x equals 4, so x equals 2. That's the coordinate 2, 0. Then we draw a line through our 2 points. Last example, x plus 3y equals 9, negative 9. So we're going to plug in 0 for x. 3y equals negative 9, so y equals negative 3. So that's the coordinate 0, negative 3. Plug in 0 for y, and we get x plus 0 equals negative 9. Uh-oh, that's supposed to be negative 9. So imagine that I'm drawing it on the other side. And so then it would have had a negative slope. But yeah, so a little mess up there, but just remember that the x-intercept actually ended up being negative 9, 0. So that point is over on the left side.